Hello class, this is the Econ 510 Managerial Economics class. Today is January 20th, Thursday, 2022. The class will move on to Chapter 3 of Chapter 4. The title is Elasticity. So the learning objectives of this Chapter 3 are: number 1, the definition of elasticity. 2, application of elasticity into the regression analysis. 3, properties and statistical significance of estimated coefficients. 4, regression specification. 5, forecasting of elasticities. Let's watch the first video clip.
Store. Right now, you're selling your ice cream cones for $2 a piece, and you're selling 20 cones a day. Should you try to improve your business by putting your ice cream cones on sale for $1 a piece? In order to answer this question, you'd need to know how your customers would respond to a change in your price. And this brings up the question of the elasticity of demand. Elasticity means responsiveness. Suppose you have a piece of elastic. If you stretch it, it responds and changes shape. If it didn't change shape, that is, if it were unresponsive to your pulling on it, it wouldn't be elastic, would it? Elasticity means the extent to which the quantity demanded changes when there's a change in the price of the good. We define elasticity as the percentage change in quantity demanded that results from a percentage change in the price of a good. Let's look at those ice cream stores now. Suppose Angie runs an ice cream store where she charges $2 a piece for her ice cream cones. And right now, she's selling 20 cones a day. If Angie puts her cones on sale at $1 a piece, she discovers that her customers want to buy more cones. That is, as the price falls, the quantity demanded increases. But they only want to buy 10 additional cones daily for a total of 30 cones per day at a price of $1 a piece. Angie's demand curve for ice cream cones looks something like this. Her customers want to buy a few extra cones when the price falls, but the demand curve is relatively steep. We'll label this D sub A for the demand on the part of Angie's customers. Across town, Barney has an ice cream store. Barney starts, like Angie did, with a price of $2 a piece for his ice cream cones. He's also selling 20 cones per day. Now, when Barney puts his cones on sale at $1 a piece, his customers get very excited and come in and buy 50 cones a day. That is, Barney's customers are much more responsive to a change in the price of cones than were Angie's customers. If we connect these two dots for Barney, we see that Barney's customer's demand curve is flatter. That is, for a given change in the price of ice cream, Barney's customers will buy many more additional cones than will Angie's customers. When the price goes from $2 to $1 at the two stands, Angie's customers respond a little, but Barney's customers respond a lot. We say that Barney's customers' demand for ice cream is more elastic than Angie's customers' demand for ice cream. Now, why should you care about this? See if you can answer this question. What happens to the total revenue that Angie raises when she changes the price of her ice cream cones from $2 a piece to $1 a piece? Does her total revenue increase or does it decrease? If you look over on the whiteboard, you can see my calculations. When the price of ice cream cones is $2 a piece, Angie sells 20 cones for a total revenue of 20 cones times $2 a piece, or $40 in total sales. When she drops her price to $1 per cone, she sells 30 cones. That means each day she earns 30 cones times $1 a piece, or $30 in total revenue. When Angie drops the price of her ice cream cones from $2 a piece to $1 a piece, Angie's total revenue actually falls. Now, what happens to Barney's total revenue whenever he drops his price? You can see my calculations. Whenever Barney is charging $2 a piece for ice cream cones, he's also selling 20 cones. His total revenue is 20 cones times $2 a piece, or $40. When Barney drops the price of his cones to $1 a piece, he sells a total of 50 ice cream cones. 50 times $1 a piece gives total revenue of $50 a day. Barney's total revenue increases when he drops his price. That is, when he has a sale on ice cream cones. You can see it's very important to know whether the demand for your product is elastic or inelastic. That is, by how much the quantity will respond to a change in the price of the good. If the quantity demanded is very responsive, your total revenue will increase when you reduce the price of your product. If, however, the quantity demanded is unresponsive or relatively inelastic, then when you reduce the price of the good, your total revenue will actually fall. Suppose you run an ice cream store. Right now, you're selling your ice cream cones for $2 a piece, and you're selling 20 cones a day. Should you try to improve your business by putting your ice cream cones on sale for $1 a piece? In order to answer this question, you'd need to know how your customers would respond to a change in your price. And this brings up the question of the elasticity of demand. Elasticity means responsiveness. Suppose you have a piece of elastic. If you stretch it, it responds and changes shape. If it didn't change shape, that is, if it were unresponsive to your pulling on it, it wouldn't be elastic, would it? Elasticity means the extent to which the quantity demanded changes when there's a change in the price of the good. We define elasticity as the percentage change in quantity demanded that results from a percentage change in the price of a good. Let's look at those ice cream stores now. Suppose Angie runs an ice cream store where she charges $2 a piece for her ice cream cones. And right now, she's selling 20 cones a day. If Angie puts her cones on sale at $1 a piece, she discovers that her customers want to buy more cones. That is, as the price falls, the quantity demanded increases. But they only want to buy 10 additional cones daily for a total of 30 cones per day at a price of $1 a piece. Angie's demand curve for ice cream cones looks something like this. Her customers want to buy a few extra cones when the price falls, but the demand curve is relatively steep. We'll label this D sub A for the demand on the part of Angie's customers. Across town, Barney has an ice cream store. Barney starts, like Angie did, with a price of $2 a piece for his ice cream cones. He's also selling 20 cones per day. Now, when Barney puts his cones on sale at $1 a piece, his customers get very excited and come in and buy 50 cones a day. That is, Barney's customers are much more responsive to a change in the price of cones than were Angie's customers. If we connect these two dots for Barney, we see that Barney's customer's demand curve is flatter. That is, for a given change in the price of ice cream, Barney's customers will buy many more additional cones than will Angie's customers. When the price goes from $2 to $1 at the two stands, Angie's customers respond a little, but Barney's customers respond a lot. We say that Barney's customers' demand for ice cream is more elastic than Angie's customers' demand for ice cream. Now, why should you care about this? See if you can answer this question. What happens to the total revenue that Angie raises when she changes the price of her ice cream cones from $2 apiece to $1 apiece? Does her total revenue increase or does it decrease? We're looking for a measure of the elasticity of demand that would be useful to a firm that's trying to decide whether to raise its price, lower its price, or keep the price of its product the same. We're going to use Barney's demand curve for ice cream as an example. Recall that when the price of ice cream is $2 at Barney's store, he sells 20 cones a day. If he lowers his price to $1 per cone, he sells 50 cones a day. We would like now to calculate a measure of the elasticity of demand that could be useful to Barney. First of all, we want a measure of elasticity that doesn't depend on the way in which we measure the units of the price or the quantity. That is, it shouldn't matter whether we measure the price of Barney's ice cream in dollars or pennies or nickels or French francs. It also shouldn't matter whether we measure the quantity in terms of cones or dozens of cones or cases of ice cream. We're looking for a unitless measure of the responsiveness of the quantity demanded to a change in price. And this is where we get our elasticity measure. An economist defines elasticity as the percentage change in quantity demanded that results from the percentage change in price. Let's say a couple of things about this measure. The first thing is, you'll notice that we write it as a fraction. Anytime we have a fraction in economics, we can read the fraction bar with these words: that results from. The percentage change in quantity demanded that results from a percentage change in price. The next thing to notice about the way we've written the elasticity measure is we put it between two bars to indicate absolute value. Remember, price and quantity vary inversely. As the price increases, the quantity demanded falls. That is, price and quantity are inversely related. This means that the fraction that compares price and quantity will always have a negative value. So we put the absolute value bars around this fraction to get rid of the negative sign. That way, the elasticity measure is always a positive number. Finally, the third thing to notice about this measure is that it is a unitless measure. When we calculate percentage changes, we get rid of the units. That is, it doesn't matter whether we're measuring the price in dollars or pennies. The percentage change will be the same in either case. Elasticity is a unitless measure of the responsiveness of quantity demanded to a change in price. Now, let's do a quick reminder of how you calculate a percentage change. To calculate a percentage change, take, for example, the new quantity demanded, subtract the old quantity demanded, and that gives you the absolute change in quantity. To turn this into a percentage change, you divide it by some base quantity, usually the original quantity or the old quantity. So, for example, in the case of Barney's ice cream store, the percentage change in quantity demanded as we move from $2 to $1 per cone will be the new quantity is 50 cones, subtract the old quantity of 20 cones, and divide by the original quantity of 20 cones to get a percentage change of 30 divided by 20, or 1.5. So there's a 150 percentage change in the quantity demanded. Divide that now by the percentage change in price. To calculate percentage change in price, take the original price of $2 per cone and subtract that from the new price of $1 per cone. $1 minus $2 is negative $1. Divide that again by the original price of $2 per cone, and you'll get a percentage change of negative 1 over 2, or negative 1/2, or negative 50%. Now, to calculate the elasticity of demand as we move from point A, the original price and quantity, to point B, the new price and quantity, we take the percentage change in quantity demanded, which is 1.5, or 150%, and divide that by the percentage change in price, which is negative 0.5, or negative 50%. That gives us negative 3 for our fraction. Now apply the absolute value bars, and you get the elasticity of demand calculated for Barney's ice cream as we move from point A to point B is 3. That is, for a 1% change in the price of ice cream, we're getting a 3% change in the quantity demanded. Now, let's do, as a calculation, the same exercise going from point B to point A. That is, let's suppose Barney starts with a price of $1 and a quantity demanded of 50 cones. And he moves to a new price of $2 and the quantity demanded of 20 cones per day. See if you can calculate the elasticity demanded as we move from point B to point A. The elasticity of demand is calculated as follows. Take the new quantity of 20, subtract the old quantity of 50, and divide by the base quantity of 50, the original quantity demanded. That gives you 20 minus 50, or negative 30, divided by 50 for negative 0.6, or negative 60%. The percentage change in price can be calculated as follows. The new price is $2, subtract the original price of $1, and divide by that original price of $1 for a fraction of 1 over 1, which gives us a percentage change of 1, or 100%. The elasticity in this case is negative 60% divided by 100%, or negative 0.6. Apply the absolute value sign, and the elasticity measure as we move from point B to point A is 0.6. Now, wait a minute. Something's wrong here, isn't it? We're getting one elasticity measure as we move from point A to B, and we're getting a different elasticity measure as we move back from B to A. Somehow that seems confusing. We'd like to have a measure of responsiveness that doesn't depend on whether we start at A and move to B, or start at B and move back to A. That is, we'd like to have one number that represents the responsiveness of quantity to a change in price that would be constant whether we're going this direction or back in the other direction. Well, the problem here stems from using different bases to calculate percentage. When we move in this direction, this price and quantity are the base of our fractions. And when we move back from B to A, then this price and quantity are the base of our fractions. That's what gives us the inconsistency. So in order to have a consistent measure of elasticity over this range of prices and quantities, we're going to use as the base of our percentage calculations the price and quantity that's halfway between A and B. We'll call this point M to represent the midpoint. When we calculate the elasticity moving along a demand curve, we use the midpoint as the basis of our percentage calculations, and that gives us a consistent measure. Why don't you try now for Barney's ice cream store to calculate the elasticity of demand, this time using as the basis of your percentage calculations the midpoint, that is the point halfway between the original price and the new price, or the point halfway between the original quantity and the new quantity. That is, calculate those elasticity numbers again, and this time use $1.50 for the basis of your percentage calculations. Then, whenever you go to calculate the change in quantity demanded, use 35 as the basis of your quantity calculations. See what you get. So, what do we have? Negative $1 divided by $1.50 is negative 2/3. Now, to calculate the elasticity of demand, take the percentage change in quantity demanded, which is 6/7, and divide that by the percentage change in price, which is negative 2/3. And what do you get? Let's solve this problem together. The percentage change in quantity demanded is 6/7. The percentage change in the price of the product is negative 2/3. So the elasticity will be 6/7 divided by negative 2/3 absolute value. Well, let's calculate that. 6/7. And remember, in order to divide by a fraction, you invert the fraction and multiply. Multiplied by negative 3/2. And we get, the 6 will cancel with the 2 to turn that into a 3, and we get as our fraction negative 9/7. The absolute value sign gets rid of the minus sign, and 9/7 is 1 2/7. The elasticity of demand, moving from point A to point B for Barney, is 1 2/7. Now, you calculate the elasticity going in the other direction. Go from point B back to point A, again using the midpoint for the bases for your percentages. In this case, the original quantity will be 50 and the new quantity will be 20. So if you take 20 minus 50 and divide by 35, this time you get negative 6/7. In this case, the new price is $2 a cone and the old price is $1 a cone. 2 minus 1 is 1, divided by 1.5 gives us 2/3. This time we've got 6/7 negative, divided by 2/3, the absolute value sign gets rid of the minus sign, and once again we have 1 2/7. The great thing about using the midpoint formula for calculating elasticity of demand is you get the same answer whether you're going from point A to B or back from B to A. This is how we calculate elasticity of demand in economics. We're studying the calculation of elasticity. For more practice now, let's consider the case of Angie's ice cream store. Remember, when Angie lowers her price from $2 per cone down to $1 per cone, the quantity demanded at Angie's store increases from 20 cones a day to 30 cones a day. What I want you to do first is forget about the midpoint formula. Forget about what I told you was the right way to solve the problem. Why don't you go back to that old way and find Angie's elasticity of demand when she lowers the price of her product from $2 per cone to $1 per cone. But start by using point A as the base point for calculating percentages. That is, use $2 as your base price and use 20 cones as your base quantity. See what you get when you calculate elasticity of demand moving from this point to this point. Now, let's do those calculations together. The new quantity is 30. Subtract from that the old quantity of 20. That gives you a change in quantity of 10 cones. You want to divide now by the original quantity, which was 20. And that gives you a total change of 10 over 20, or 1/2, a 50% change in quantity demanded. Now divide by the percentage change in price. The price goes from $2 to $1, take the new price of 1, subtract the old price of 2, that gives you -1, and divide by the old price of 2. Now we have -1/2, or -50%. If we take 1/2, the percentage change in quantity, and divide by -1/2, the percentage change in price, we get -1. Then apply the absolute value sign to get rid of the minus, and the elasticity measure, calculated moving from point A to point B, using point A as the base point, is equal to 1. We call this unitary elasticity, or unit elastic. Now, go from point B back to point A. That is, calculate the elasticity of demand as we move from a price of $1 up to a price of $2, and the quantity falls from 30 to 20. Only this time, use point B as the base points for your percentage calculations. That is, use $1 as your base price, and use 30 cones as your base quantity. See what you get. All right, the new quantity is 20 cones. Subtract the old quantity of 30 cones and divide by 30 to get -1/3 as the percentage change in quantity demanded. The percentage change in price will be the new price of $2 minus the old price of $1 divided by that old price of $1, which gives us 1/1. So we have -1/3 over 1, which is -1/3. Apply the absolute value sign, and you get the elasticity measure moving from point B to point A, using B as the basis for your percentage, is equal to 1/3. Aha! We've recreated that problem that we had with the demand curve originally, with Barney's demand curve. We've recreated the problem that we get a different elasticity measure moving from A to B than we get when we move back from B to A. And that problem is all related to the way you measured percentages. Now, you know what the right way to solve the problem is. You know how to get a consistent measure moving from A to B or B to A. That is, you want to use as the basis for your percentages the point halfway between A and B. You want to use this midpoint in order to calculate the price and quantity percentage changes. The midpoint will be $2 plus $1 divided by 2, or $1.50. $1.50 will be the midpoint price. The midpoint quantity will be 20 plus 30, which is equal to 50, divided by 2 equals 25. Now, calculate the elasticity of demand for Angie's ice cream store as you move from a price of $2 down to a price of $1. Only this time, use the midpoint formula. That is, use $1.50 as your base price. The new quantity is 30. The old quantity is 20. 30 minus 20 is 10. Divided by the midpoint quantity, which is 25, gives you 10 over 25, or 2/5. 2/5, or 0.4, is the percentage change in quantity demanded. The percentage change in price now will be the new price of $1 minus the old price of $2, that is -1, divided by the midpoint price, which is $1.50. And that gives you -1 over $1.50, or -2/3. So what we have here is 2/5 divided by -2/3. Apply the absolute value sign and multiply out, and you get 3/5. 3/5 is Angie's elasticity of demand moving from A to B using the midpoint as the basis of your percentages. Now, just as a check, find the elasticity of demand as you move from B back to A, again using the midpoint as the basis for your percentage. In this case, the new quantity is 20 minus the old quantity of 30 divided by 25 is -2/5. In this case, the percentage change in price will be the new price of $2 minus the old price of $1 divided by $1.50, for a percentage change of 2/3. Once again, applying the absolute value sign and multiplying out those fractions, we get the elasticity of demand for Angie's ice cream is 3/5, or 0.6. Notice then it doesn't matter whether you're going from A to B or B to A. Once you're using the midpoint formula, you get a consistent measure of the elasticity of demand in either direction. Notice that in Angie's case, the measure of the elasticity of demand is 0.6. That is, it is less than 1. If the elasticity of demand for your product has an elasticity number of less than 1, we say that the demand for your product is inelastic. That is, a given change in the price of your product results in a relatively small change in the quantity demanded. You can lower your price by a fair bit and not get a significant increase in the sales of your product. In this case, what happens is the smaller price has a big impact on your sales revenue. You're making less money on each unit of the good that you sell. And since you're not bringing in a lot of extra customers, your total revenue suffers. Anytime the demand for your product is inelastic, anytime your customers are relatively unresponsive to a change in the price of your product, total revenue will fall when the price of your good is decreased. If we go back to Barney's store, we'll see that his measure of elasticity was greater than 1. In fact, it was 1 2/7. What that means is a given change in the price of Barney's product or in Barney's market results in a relatively large response of customers. When Barney cuts his price by $1, he brings in a lot of new customers. And even though he's making less money on each ice cream cone than he was before, he's bringing in so many additional customers that his total revenue actually increases. Anytime the demand for your product has an elasticity measure greater than 1, we say that the demand for your good is elastic. And in that case, a reduction in the price of your good generates a big response from your customers, and total revenue increases. So, to summarize, if the demand for your product is inelastic, a reduction in the price of your good results in less total revenue. If the demand for your product is elastic, then reducing your price will increase your total revenue. If elasticity of demand for your product is exactly equal to 1, then the change in price and the change in quantity demanded exactly offset each other, and there is no change in total revenue. And use 25 as your base quantity. See what you get.
Now we're going to learn about a very important topic called elasticity. Elasticity looks at the responsiveness of one variable to another. And so what we're going to look at first is the price elasticity of demand. Now this looks at how much the quantity demanded changes when there's a change in the price of that good. We know the law of demand gives us a downward sloping demand curve. So if we look at the price and the quantity and the relationship between the two, we know that it's a negative relationship. But the price elasticity of demand talks about a quantitative measure of how much there is a change in the quantity demanded when there's a change in the price level. So when we look at the price elasticity of demand, the way we're going to calculate it is we'll take the percentage change in the quantity demanded and divide it by the percentage change in price. So if we look at 2 points on a demand curve, we can look at what the change in the price is between these 2 points and the change in the quantity between these 2 points. And the percentage change in the price and the percentage change in the quantity are the two numbers that go into the elasticity of demand, the price elasticity of demand equation. and we're going to take absolute value of it to get the measure of price elasticity. Now let's see what we do with that. In this table we can see a couple of examples of how to calculate and compute the percentage change in price elasticities. So suppose we had the data that our initial point on a demand curve had a price of 20 and a quantity of 100, and the new point, the one we've moved to, has a price of 22 and a quantity of 80. To calculate the percentage changes, we can look at the percentage change of price. It's 10%. The change in price is $2. The initial price was 20, so $2 divided by 20 times 100 gives us 10%. The percentage change in quantity is the change of negative 20 divided by the initial quantity of 100 times 100, we get negative 20%. The price elasticity of demand, using the initial value method of calculating percentage changes, the price elasticity of demand is 2, which is the absolute value of negative 20 divided by 10% is 2. Another alternative way of calculating percentage changes is using the midpoint method. The midpoint method substitutes the average or the midpoint of the two prices for the initial price. So in the initial way, the way we looked at it before, the way we computed it using the initial value method, we had the initial price level and the initial quantity. If we use the midpoint, we put in the midpoint price and the midpoint quantity. We get a slightly different measure for elasticity. Now let's look at a demand curve and look at whether we have what we call an elastic or an inelastic demand curve. Here's our demand curve, and we can look at two different points. This point where the price is $6 and this point where the price is $5. And at this point, the quantity demanded is 12, and at this point, the quantity demanded is 20. So what's the elasticity, price elasticity of demand? Well, we look at the percent change in quantity and the percent change in price. So if we move from this point to this point, our percent change is a negative 40% change in the quantity demanded, and the price has gone up by 20%. So when we look at the price elasticity of demand, that is 2.0, which is greater than 1. And we call this an elastic demand curve because the percent change in quantity is greater than the percent change in price. You can think of it in a way of when something is elastic, it's very responsive or very flexible. And so when there's a relatively large change in quantity for a given change in price, we call that an elastic demand curve. Elastic means the price elasticity is greater than 1. For this demand curve, we have what's called an inelastic demand curve. When we calculate the price elasticity moving from this point to this point, we get a price elasticity of 0.5, which is less than 1. This is an inelastic demand. Inelastic would be not very responsive or not very flexible. So we see a relatively small percentage change in quantity for a relatively larger percentage change in price. So our price elasticity comes out to be less than 1. For this demand curve, for this portion of the demand curve, and we're moving from this point to this point, our price elasticity turns out to be exactly equal to 1, and we call that a unit elastic demand. Another potential elasticity is perfectly inelastic demand. That's a vertical demand curve. When you think about it, perfectly inelastic would be non-responsive or non-flexible. So no matter what percentage change in price we have of this demand curve, we can see there's zero change in the quantity demanded. So the percent change in quantity demanded is 0, and the price elasticity is 0. So for a perfectly inelastic demand curve, the price elasticity is 0, and the quantity demanded is not responsive at all to changes in the pool. Perfectly elastic is the diametrically opposite of perfectly inelastic. A perfectly elastic demand curve is flat, and we can see any change in the price would lead to an infinite change in the quantity demanded. So perfectly elastic demand has a price elasticity of infinity. Well, here's some examples of elasticity, price elasticity for different goods and services. Here's an estimate of the price elasticity of salt of being 0.1. So we can see that that's a very inelastic demand for salt. So no matter what the change in price is, the demand for salt is not going to be very responsive. Go to the other side, we have air travel. The estimate for the price elasticity for air travel is 2.4. A change in the price of air travel is going to lead to a relatively large change in the quantity demanded for air travel. So you can look through these different goods and services and look at their price elasticities and try to think about why it is that specific brands of coffee have a very high responsiveness to changes in price, whereas weekend canoe trips have a very low price of elasticity of demand. There are several things that determine the price elasticity of demand. One of those is the availability of substitutes. If there are many substitutes, the demand is going to be very elastic, because if the price of a good changes, you can just go to one of the substitutes. If there are few substitutes, demand is going to be inelastic, because no matter what happens to the price, you're going to have to stay with the same good or service. As time goes on, the longer time that passes, the more elastic demand is going to be, because you can find more substitutes or you can change your behavior. The fraction of your budget. And if it's a large fraction of your budget, you're going to have a relatively elastic demand, because it's taking up so much of your budget, you're going to look for substitutes and alternative ways to demand. And if it's a necessity, if the product is a luxury, it's going to be relatively elastic. If the product is a necessity, it's going to be inelastic. Now let's look at the other side of a market and talk about the price elasticity of supply. We know that when we look at a supply curve, it's upward sloping. So when we look at the relationship between price and quantity supplied, the law of supply says it's going to be a positive number. But the elasticity of supply looks at the percentage change in the quantity supplied for a percentage change in price. So it's a measure of the responsiveness of the quantity supplied to changes in price. Here are two supply curves we might look at. And this is a relatively steep supply curve compared to this relatively flat supply curve. So if we look at the price elasticity of supply, for this supply curve, we can see that the percentage change in quantity is relatively small compared to this percentage change in price. Meaning the supply curve, or the quantity supplied, is not very responsive to changes in the price level. This is an inelastic supply curve. This would be an elastic supply curve because it's relatively flat. A relatively small percentage change in the price level gives you a very large percentage change in quantity. This is an elastic supply curve. So the price elasticity of supply is different for different goods and services. And what determines the price elasticity of supply? We're looking at a supply curve and trying to determine how responsive changes in quantity are to changes in price. So in an industry, if marginal costs increase rapidly as production goes up, then it will take a large change in prices to get a small change in quantity. And that's going to be an inelastic supply curve. The price elasticity of supply is determined by how rapidly production costs increase as total output goes up. Additionally, we want to look at the time frame that we're looking at. Again, we're trying to figure out what happens to the quantity supplied as price goes up. Well, if prices rise, in the short run, what we'll see is firms already in the market are going to increase their output. They're going to purchase more materials, they're going to hire more workers. But in the long run, we're also going to see new firms enter. So in the short run, we're going to have an increase in output. In the long run, we're going to have an even more significant increase in output, because not only are the existing firms going to increase how much they produce, but new firms are going to enter the market. So the short-run response might be limited, while the long-run response will be larger. So the long-run supply elasticity is going to be more elastic than the short-run supply elasticity. Here are the extreme cases. Here's a perfectly inelastic supply curve. This says that the quantity supplied is going to be 50 no matter what happens to the price. So the percent change in quantity is 0. And so this is a perfectly inelastic supply curve. And this is a perfectly elastic supply curve, meaning any change in price is going to give you an infinite change in the quantity supplied. So perfectly inelastic, the price elasticity of supply equals 0. Perfectly elastic, price elasticity of supply is equal to infinity. Now, just like we did for demand, we can use the price elasticity of supply to predict changes in the quantity supplied. Suppose we want to know the percentage change in quantity supplied. All we need to know is what the price elasticity of supply is and the percentage change in the price. If we multiply those two together, we'll get the percentage change in the quantity supplied. Now, an interesting thing about price elasticity and demand curves is that even for a demand curve which is linear, meaning it has the same slope, so the change in price for a given change in quantity is the same anywhere on the demand curve, the price elasticity changes. Now, why is this the case? Well, if we look at this section of the demand curve up here, where it's elastic, we can see that a change in price is going to be a relatively small percentage change because the prices are so high. And a change in quantity is going to be a relatively large percentage change. So if we remember what the formula for elasticity is, it's the percent change in quantity divided by the percent change in price. A large percent change in quantity relative to percent change in price is elastic. And as we've learned, on the elastic part of a demand curve, as the quantity goes up, so does total revenue. So anywhere on this part of the demand curve, total revenue is going to rise because the price is going to change a little bit and it's going to increase quantity a lot. Right? So if you dropped your price a small percentage change, the percentage change in quantity is going to increase more. So total revenue is going to rise. Down on the inelastic portion of the demand curve, changes in quantity in percentage terms are relatively small compared to changes in prices on the inelastic portion of the demand curve. So anywhere on the inelastic portion of the demand curve, a decrease in price, which increases quantity demanded, is going to decrease total revenue. So we can see total revenue on a linear demand curve reaches a maximum where the demand curve is unit elastic. Now let's look at some examples. Suppose we look at the price elasticity along a linear demand curve, and we're going to look at the same percentage change, the same dollar change in price and the same unit change in quantity everywhere on this demand curve. So if we look at our demand curve, and it's a linear demand curve, and we look at the same unit change in price and quantity between two different points, several places on the demand curve, we can look at what our elasticity of demand turns out to be. Suppose we're on the elastic portion of the demand curve and the price goes down by $2 and the quantity goes up by $1, but we're in this section of the demand curve. So a $2 change in the price is a relatively small percentage change because the initial price is very high. And in this section of the demand curve, prices are very high. So a $2 reduction is a relatively small percentage change. Now, when we look at the demand curve in this portion, quantities are relatively small. So a 1 unit increase in quantity is a relatively large percentage change. So we have a large change in quantity divided by a small change in price in percentage terms. That gives us an elastic demand curve. Now, if we look at the same quantitative changes in this portion of the demand curve down here, where we've got a $2 reduction from one point to another and a 1 unit increase from one point to another, we can see the percentage changes are very different on this section than they are in this section. That $2 reduction is a decrease in $2 from an initial price which was much lower. So the same reduction is a much larger reduction in percentage terms when we start out down here. When we look at quantity, we have the same increase of 1 unit. However, it's an increase of 1 unit from a much larger initial quantity, so the percentage change is much smaller. And when we look at elasticity, we get a much smaller elasticity, and it's an inelastic portion of the demand curve. Now let's put our concepts of price elasticity of demand and supply together and try to predict what's going to happen in a market. Now suppose we look at an equilibrium and we have a supply curve and a demand curve, and something happens and the demand curve shifts. If the demand curve shifts out, we know that the price level is going to go up. But how much is it going to go up? Let's ask the question, under what conditions will an increase in demand cause a relatively small increase in price? Well, this will happen if maybe the supply curve is relatively flat, or demand curve doesn't shift very far, or maybe the demand is highly elastic. Now, we can actually look at a formula that tells us exactly how much the price is going to change. And here's that formula. We can say the percentage change in the equilibrium price is equal to the percentage change in demand divided by the price elasticity of supply plus the price elasticity of demand. Now let's use this formula to actually answer a question related to how much will the price change. Here's an example where we have an initial demand curve which shifts out to a new demand curve, and we have a supply curve. And now at the initial equilibrium, we can see that there was a price of $1 and the quantity of 100 million gallons, and we're looking at a market for milk here. As the demand curve shifts out, we can see that the price is going to go up to $1.10, and the quantity is going to go up as well. How much is the price going to change? Well, in this case, there's been a 35% increase in demand. That's how far it shifted over to the right. And we know that because the horizontal shift of the demand curve was 35%. It went from 100 to 135. So our demand curve has shifted 35%. In this example, we're assuming that the price elasticity of demand and the price elasticity of supply are 2.5 and 1.0. So when we add these two together, divide 35% by it, we can get a 10% increase in the price level. Now what if we have a supply shift? In this market, we're going to look at shoes and the price per pair of shoes. Suppose supply decreases. How much does it decrease? It's going from 100 down to 70. So there's a 30% reduction in supply. And we can look at a formula to figure out how much is the price going to change. Now that formula is going to be very similar to the one we looked at for demand, where we're going to take the price elasticities of supply and demand, and add them together, divide that into the percent change in the supply curve, and that's going to give us the percent change in price. Here's that formula. Percent change in the equilibrium price of the good is equal to the percent change in supply divided by the elasticity of supply plus the elasticity of demand. And we want to multiply it times -1 because we're moving along the demand curve. In economics, we talk a lot about price elasticities, but there are other elasticities as well. In particular, when we look at demand, we can calculate a price or an elasticity for any change in a variable that affects the quantity demanded. For example, income. There's an income elasticity of demand, and it's very similar because we look at the percent change in quantity demanded and divide that by the percent change in income. And this looks at the responsiveness of quantity demanded to changes in your income. We can also look at cross-price elasticity. We know that the price of other goods will affect the demand of a given good because they might be a substitute or a complement. So when we look at the cross-price elasticity of demand, this measures the responsiveness of the demand for one good, say good X, for a change in the price of another good, and it's computed by looking at the percent change in quantity of X demanded divided by the percent change in the price of Y. If we want to look at what different types of goods have for income and cross-price elasticities, we can say an income inelasticity for a normal good has a positive income elasticity. For an inferior good, it's negative. Because remember, for a normal good, when the income rises, the quantity demanded rises. For cross-price elasticities, a substitute good has a positive cross-price elasticity. Why is that? When the price of good Y goes up, if X and Y are substitutes, you're going to buy less Y and more X. So the percentage change in Y is going to be positive. Percentage change in the quantity of X demanded is also going to be positive. So the cross-price elasticity will be positive. For complementary goods, the cross-price elasticity is going to be negative. Now that we know what price elasticity of demand is, and we know how to calculate it, let's see how we might be able to use it. One way to use the price elasticity of demand is to predict changes in quantity. And if we have the values of 2 of the 3 variables in any formula, we can always solve for the third one. So remember that the elasticity of demand is equal to the percentage change in quantity divided by the percentage change in price. So if what we know is 2 of these 3 variables, so suppose we know what the elasticity is and we know what the percentage change in the price is, we can calculate what the percentage change in quantity demanded is. Right? So that's going to be the percentage change in quantity demanded is going to be equal to the percentage change in price times the elasticity of demand. Now let's see how we might use this formula. Once we know the percentage change in price and the elasticity of demand, we can calculate some very interesting outcomes. An ongoing policy objective of the federal government in the United States is to reduce smoking by teenagers. In 1997, there was a settlement that was reached that increased the price of cigarettes by about 62 cents per pack. This is a 25% increase in the price. So we know that the percent change in the price equals 25%. Now the demand for cigarettes by teenagers is elastic, and the elasticity of demand for cigarettes for teenagers is 1.3. Therefore, if we know that there's a 25% change in the price and that the elasticity is 1.3, if we multiply these two numbers together, we're going to get a 32% reduction or change in the quantity demanded of cigarettes. So this is going to decrease the quantity demanded of cigarettes by teenagers, and we can put a quantitative number on the decrease. Another reason you might want to look at price elasticity is if you're a business and you're trying to figure out what your total revenue is. The total revenue is the money a firm generates from selling its product. How much money comes in when you sell a good or a service. The way to calculate total revenue is to take the price per unit and multiply it times the quantity sold. And so how many are you selling and at what price? Multiply the two together. That gives you total revenue. So what happens to total revenue if the price of a good or a service goes up? If we look at the demand curve, we can say if you're selling this good and you were originally charging this price and selling this quantity, there's good news and bad news if your price goes up. And an increase in price means you have to slide along the demand curve to determine how much you can sell. So we can see the good news is the price of everything you're selling is higher. The bad news is you're selling less. So what's the impact on total revenue? The effect on total revenue depends on which is bigger. Does the price go up more, or does the quantity go down more? And it all depends on whether elasticity is greater or less than 1. And suppose the elasticity of demand is 2.0, so we have an elastic demand. Well, in this example, when the price goes from 10 to 11, you've had an increase in price of 10%. So for an elastic demand and one with a price elasticity of 2.0, an increase in price of 10% is going to reduce the quantity demanded by 20%. So if the quantity was 100, it's now 80. Total revenue goes from 1,000 down to 880. Remember, to calculate total revenue, you just multiply the price times the quantity. So total revenue falls for an elastic demand. What about an inelastic demand? Now, if the price elasticity is 0.5, here we've got a 20% increase in price, but only a 10% decrease in the quantity demanded. So we can see that total revenue is going to rise. So when we look at the effect of a change in the price on total revenue, we need to know what the elasticity of demand is. For an elastic demand, or one with an price elasticity greater than 1, an increase in price is going to decrease total revenue because the percentage change in quantity is larger than the percentage change in the price. Remember, elasticity is calculated as the percentage change in quantity divided by the percentage change in price. So if it's greater than 1, the percentage change in quantity is greater than the percentage change in price. So if the price were to fall, total revenue rises. Now for an inelastic demand, one where elasticity of demand is less than 1, now the percentage change in quantity is smaller than the percentage change in price. So if the price rises, total revenue is going to go up. And if the price falls, total revenue is going to go down. Price elasticity and elasticities in general are a very important concept to understand when we're trying to predict what's going to happen to total revenue, what's going to be the effect of policies, or how is a change in one variable, in this instance the price, going to affect another variable, again in this instance the quantity demanded.
The elasticity of demand is the responsiveness of the quantity demanded to changes in the price of the good. We've discussed how to calculate the elasticity of demand, and we've also discussed the relationship between elasticity of demand and total revenue. One question remains. What determines the elasticity of demand for a particular product? What determines whether the demand for a product is elastic, that is, very responsive to changes in the price of the product, or whether it's relatively inelastic, that is, a large change in the price of the product may not produce a sizable change in the quantity demanded. What's the difference between goods with elastic demand and goods with inelastic demand? The first and probably most important determinant of the elasticity of demand is the availability of close substitutes. Products that have a lot of close substitutes are likely to have more elastic demand. For example, if one airline decides to raise the price of its tickets, customers can switch to another airline and fly perhaps to the same destination. The availability of substitutes makes the demand for a particular airline ticket relatively elastic. The demand for a particular kind of soda might also be elastic. If one company raises the price of its soft drinks, customers may switch to another comparable drink. Elasticity of demand often follows from the availability of close substitutes. The more substitutes are available, the more elastic the demand for the product is likely to be. The more close substitutes, the more price responsive. Products that are inelastic in demand are likely to be those that have no close substitutes available, or few good close substitutes. For example, the demand for insulin to treat diabetes is usually viewed as inelastic. Whatever the price of insulin is, a diabetic is likely to pay it rather than do without, because there are no good substitutes. However, even insulin is not a perfectly inelastic good. As the price of diabetic treatment goes higher and higher, some people who suffer from diabetes may look to alternative ways of managing their condition. They may choose to exercise more rigorously or watch their diet more closely, as opposed to paying higher and higher prices for the medicine. It's difficult to come up with any product that's going to be completely unresponsive, any product that has no substitutes at all available. Even though you need gasoline to make your car go, it may be that if the price of gasoline gets high enough, you will stop driving your car altogether and use mass transportation, or walk, or simply make fewer trips. The point I'm trying to make is this. If there are few close substitutes available for a product, the demand for that product is likely to be unresponsive to changes in the price of the good. When there are few close substitutes, people have to buy that product, and their demand for the product is unresponsive or inelastic. On the other hand, the more close substitutes there are available, the more likely you are to get elastic demand, that is, highly price-responsive quantity demanded. The second determinant of the elasticity of demand is time. The more time you have during which to search for substitutes, the more likely your demand will be elastic. Suppose I'm building a house, and I think I need lumber for framing my house and finishing it. If the price of lumber goes way up, and I have to make a decision now, I'm likely to just swallow the extra cost and finish my house with lumber. But if I have 2 or 3 months to make a decision, 2 or 3 months to search for a substitute, then I'm more likely to hold out and look for a possible alternative. During those months, producers may convince me that steel framing is a very good substitute for lumber. As lumber prices rise, producers will begin to offer customers alternatives. Alternatives don't come online quickly, so the more time you have to get an alternative, the more likely you are to find an acceptable substitute, and the more price responsive your demand for lumber will be. That is, the more time you have for making a decision, the more likely you are to find a good substitute, and therefore the more price responsive your demand will be. The third determinant of the elasticity of demand is the percentage of your budget that is spent on the good in question. If you consider your elasticity of demand for bubblegum, your demand for bubblegum is probably relatively inelastic. That is, when the price of bubblegum goes up from 2 cents a piece to a nickel a piece, you probably don't change the quantity that you consume during a week. Your demand for bubblegum is inelastic because bubblegum is not a big percentage of your budget. You may not even look at the price tag when you purchase gumballs. On the other hand, if you consider your demand for housing, your housing cost is such a large percentage of your budget that if your apartment rent were to go up by 20%, you may have to look for another place to live or take in a roommate. Because housing occupies a large chunk of your budget, your quantity demanded will be responsive to a given percentage change in price. Well, as a quick summary then, your demand for a product is likely to be more elastic if there are close substitutes available, if you have lots of time over which to search for substitutes, and if the product in question occupies a big chunk of your budget, so that price changes really require you to make some kind of adjustment. On the other hand, your demand for a particular product is likely to be inelastic or non-price responsive if there are not good substitutes available, if you have to act quickly and don't have time to search for substitutes, and finally, if the good in question occupies a small chunk of your budget so that you don't have to change your behavior when the price changes. These 3 factors are likely to influence whether the demand for a product will be inelastic or elastic. And as you know, once you know which it is, you can say how a change in price will affect total revenue raised in that market. Inelastic demand means that lower prices shrink total revenue. Elastic demand means that lower prices increase total revenue.